In this lecture, we're going to learn about snapshot testing. From the very beginning, I mentioned three types of tests: unit testing, snapshot testing, and end-to-end testing. Up until now, we've been focused on unit testing. We're finished with unit testing for this section. It's time to move on to the second category of testing, which is snapshot testing. The question is, what is snapshot testing? Snapshot testing is when two images of an application are compared. It's similar to the game Spot the Difference. The comparison is performed by a machine instead of a human. It's much faster and accurate. We're going to be using Vitest to write snapshot tests. It's primarily a unit testing library, but can handle all our snapshot testing needs as well. There's one problem with snapshot tests. They can be unreliable sometimes because images may come out differently each time. If we're using different browsers or window sizes between each test, Vitest will produce an error. If an image is off by 1 pixel, this can cause our tests to fail even if we didn't change anything in our tests or application. Vitest solves this issue by serializing the application. A serialized value is a string that initially wasn't a string. This means Vitest will compare two strings instead of two images. This process provides for a more consistent, reliable, and faster testing result. Vitest performs serialization on the DOM. It'll take care of saving the snapshot for you. Let's review the steps taken by Vitest for performing snapshot testing. Firstly, Vitest will search for an existing snapshot. If it's the first time the test is running, it'll generate a snapshot. The snapshot will be saved. Lastly, the test will pass as long as it's able to save the snapshot. Vitest takes care of saving the file for you. We'll look at how that's done when we begin writing the test. If a snapshot exists, it'll generate a new snapshot. The latest snapshot will be compared to the last generated snapshot. If the two snapshots don't match, the test will fail. If they match, then the test will pass. This is a high-level overview of how snapshots work. There are two important points I want to make about snapshot tests. The first point is that snapshot tests should always pass if you haven't made any changes to your application or test. You will need to run snapshot tests at least 2 times before considering them a success. The second point I want to make is not to write so many snapshot tests. They're highly susceptible to failure. If you change a single class, element, component, or text, then your snapshot test will fail. If the change you made were intentional, then you'll need to update your snapshot tests. The more snapshot tests you have, the more fixes you'll have to make. Generally, I like to write a snapshot test for every component. Sometimes I may need to write multiple snapshot tests for a single component. I try my best to keep it under 3. Usually, 1 snapshot test per component is all you'll need. Let's begin writing a snapshot test. Snapshots are easy to write. We'll create a snapshot test for the song item component. It's the perfect candidate for a test. It's easy to isolate, and we can test if dynamic data is rendered properly inside the component. In the tests directory, create a file called snapshot.spec.js. We'll need to import the shallow mount function and song item component. Create a describe block with the following identifier: snapshots song item.view. Inside the block, add a test block with the following description: renders correctly. The first thing we'll do is create the prop data. The song item component expects the parent component to supply it with the data. In previous tests, we would provide the song item component with bits and pieces. This is because we were interested in only testing specific parts of the component. Things will be different with a snapshot test. The goal of any test is to test against the output. With snapshot tests, we'll specifically want to test the output of an entire component. The output of a component is the template. We'll want to make sure the template has everything it needs to be able to render correctly. In this case, we'll want to supply the song item component with a full object. Create a variable called song. It'll be set to an object. There are 4 properties the component needs in order to render correctly. They're the document ID, modified name, display name, and comment count properties. You can assign them any value you'd like. Next, let's mount the component. Create a variable, set it to the shallow mount function with the song item component passed in. For the second argument, we'll pass in an object. We can add the component's prop data by adding the props data object. We'll pass in the song variable. We're almost done preparing the component. The song item component uses the router link component to create links. We'll need to stub this component. We'll update the import statement for the View Test Utilities module to include the router link stub component. Back in the shallow mount options, we'll add the global object. Inside the object, we'll add the components object. Lastly, we'll set the router link component to the router link stub component. This property will replace the router link component with a dummy output. Let's write the assertion. We'll call the expect function. Pass in the wrapper.element property. The element is the root DOM element in the component. Snapshot tests require the element as the input. After providing the input, we'll chain the toMatchSnapshot function. The toMatchSnapshot function does a couple of things. It'll generate a snapshot using the input we've provided in the expect function. Afterward, it'll compare the snapshot it's generated with an existing snapshot. If a previous snapshot doesn't exist, it'll create a file with the snapshot it generated. The file will be saved in a special directory. If a snapshot does exist, it'll compare the generated snapshot with the previous snapshot. The test will pass if the snapshots match. Let's run the tests. In the View UI, run the task. The tests will pass successfully. The report will tell us that a snapshot was written. Let's go back to the editor to find where the snapshot was written. Snapshots are created under a directory called snapshots. You can find it in the tests directory. Inside this directory are snapshot files. Every snapshot file is saved with the snap extension. Let's open the snapshot file that was created. Syntax highlighting is not available because Visual Studio Code does not support snap files by default. We can enable syntax highlighting by installing the official Jest extension. Under the Extensions tab, search for an extension called Jest. Click Install. Initially, this extension might seem strange. However, Vitest's snapshot testing feature was inspired by Jest's snapshot testing feature. Unfortunately, there isn't an extension for highlighting syntax in a snapshot file produced by Vitest. For this reason, we must install the Jest extension. The extension will be enabled globally. It should work out of the box with our project. It'll add a lot of features for helping us with testing. We're installing it to enable syntax highlighting. Switch back to the snapshot file. You should be able to read the file more easily with the extension installed. Vitest has converted the root element into a string. If you were to look through the string, you should see the component was compiled without a problem. Every expression was interpolated with the corresponding property. This was our first time running the test. The test will pass automatically if the file was generated successfully. As I mentioned earlier, snapshot tests should pass if there weren't any changes to the tests or application. Let's run the test again to see if it passes. It indeed does. The report is slightly different this time. Vitest will not rewrite the snapshot file because there weren't any differences. It'll simply pass the test. This is great if you didn't change anything. However, in some cases, you will eventually need to change something. When that happens, the snapshot test will fail. Let's look at an example. Open the Song Item component in the editor. We're going to update the class attribute on the root element. We'll add the class Snapshot. This is a fake class. It doesn't do anything. Its purpose is to showcase what happens when a snapshot fails. Back in the UI, rerun the test. The test will fail. Unfortunately, the test from the browser isn't helpful. If we're interested in viewing the differences, we must check out the command line. A report will tell us where things don't match. This result is what's called a diff. A diff is a comparison between the previous snapshot and the latest snapshot. It'll help you locate where there's a difference. It's telling us that the class attributes don't match. Let's say that we want the snapshot class to exist in the Song Item component. This is an intentional change. In this case, we'll need to update the snapshots. There's a command that'll update every snapshot test. It's not written for us. We'll need to run it ourselves. Luckily, there's an option for doing so. Press the U key on your keyboard. ViteTest will listen for keyboard presses on the command line. If we press the U key, all snapshot files will be updated. After updating the snapshots, ViteTest will run our tests again. The report will tell us that the snapshot was updated before it was tested. The test passed without a problem. That's all there is to snapshots. The purpose of a snapshot is to check if a component is rendering fully. Unlike unit tests, where you need to write multiple test blocks for a single component, most components will only need a single snapshot test.